Imagine looking up at the night sky, that endless black ocean sprinkled with stars. For centuries, comets have been our cosmic visitors, icy wanderers with fiery tails, always obeying the same rules. Their bright streaks reminded ancient civilizations of omens, gods, and destiny. But behind the myth and mystery, science eventually gave us certainty. Comets are predictable. They are frozen relics of the early solar system, their tails always pushed away from the sun by its fierce wind and light. A simple rule, tested and true. Until now, because in July of 2025, astronomers caught something that shattered this certainty. An object, moving faster than nearly anything we had ever seen, came hurtling into our solar system. At first, it looked like a comet, but as telescopes locked onto it, the story took a turn that no one expected. Its tail wasn't obeying the laws of physics. Because in July of 2025, astronomers caught something that shattered this certainty. An object, moving faster than nearly anything we had ever seen, came hurtling into our solar system. At first, it looked like a comet, but as telescopes locked onto it, the story took a turn that no one expected. Its tail wasn't obeying the laws of physics. Instead of streaming away from the sun like every comet we've ever studied, this plume of gas and dust was pointing toward the sun, as though something inside the object was firing against the solar wind, like a rocket engine fighting upstream. For a moment, the astronomy world froze. Then the whispers began. Could this be a mistake in the data, a glitch in the telescopes? But as more observatories joined in, Hubble, Gemini South, the James Webb, the evidence only grew clearer. This was no illusion. This object was doing something that no natural comet should be able to do. Its name was given quickly, 3I Atlas. 3I, because it was only the third interstellar object ever discovered. Atlas, because it was spotted by the NASA-funded Asteroid Terrestrial Impact Last Alert System in Chile. But names can be deceiving, and from the moment of its discovery, 3I Atlas seemed to resist every label we tried to put on it. It wasn't just the tail. Its path was eerily suspicious, almost perfectly aligned with Earth's orbit within just 5 degrees. The odds of such precision happening by chance, astronomers calculated it as less than 1 in 500. And as if that weren't enough, its route would take it past Mars, Venus, and even Jupiter, as though this visitor had planned a grand tour of our neighborhood. The odds of that alignment were 1 in 20,000. Coincidence? Maybe. But when you stacked anomaly on top of anomaly, coincidence started to look a lot like intention. And that's when NASA did something almost unthinkable. In their technical notes, buried in cautious, carefully chosen language, they admitted what nobody wanted to say out loud. This wasn't just a comet behaving strangely. This was a comet acting like it had a propulsion system. Let that sink in. A natural body, billions of years old, flying in from deep interstellar space, behaving as if it were a machine. The idea spread like wildfire. Across online forums, scientific conferences, and late-night debates in observatories, the whispers grew louder. Could this be it? Could this be the first time humanity has stumbled upon something not just natural, but engineered? Some dismissed it, waving their hands at unknown outgassing or rare chemistry. Others leaned in closer, pointing to the parallels with Oumuamua, the first interstellar object detected back in 2017, which also moved in ways gravity couldn't explain. Back then, the idea of an alien probe was laughed out of most conference halls. But now, in 2025, with a second cosmic anomaly unfolding in real time, those same whispers carried more weight. And the strangest part, 3I Lash wasn't trying to hide. Where Oumuamua was silent, without a visible tail, this object flaunted its mystery. Its plume burned bright like a cosmic smoke signal, daring us to notice. NASA's own models confirmed what the eye could already see. The force pushing 3I Atlas was too steady, too strong, too directed to be explained by ordinary comet activity. It was as if someone had mounted an ion engine on a comet and pointed it toward the sun. And so the questions began to pile up. If it's natural, what kind of natural phenomenon could do this? Why the bizarre chemistry, the absence of iron, the overwhelming carbon dioxide? Why the precision in its trajectory? Why now, just years after Oumuamua? And if it isn't natural, then who built it, and why is it here? That's the story we're about to explore. Over the next hour, we'll unravel the discovery of 3I Atlas, its impossible tail, its engine-like acceleration, its chemical riddles, and the chilling theories that scientists and thinkers are now daring to entertain. When NASA confirmed the discovery of 3I Atlas, the initial statements were calm, almost routine. Another interstellar visitor, they said. Another chance to learn about the cosmic debris drifting between the stars. But behind the cautious wording, something else was brewing. For the first time, scientists were staring at an object that refused to play by nature's rules. The problem was the tail. Every textbook explains that a comet's tail is formed when sunlight heats its icy surface, releasing gas and dust that the solar wind pushes outward, always away from the sun, no exceptions. But with 3I Atlas, the tail wasn't obeying the rule. It was locked in place, pointing directly toward the sun, as though the object was fighting against the very star pulling it in. Hubble's images confirmed it. Night after night, astronomers expected the plume to shift, to snap back into line with solar wind pressure. It never did. Instead, it burned on stubbornly, a constant reminder that something was wrong. NASA's data analysts turned to astrometric tracking, measuring the object's position to precision within a fraction of an arcsecond. And what they found was more unsettling than the images themselves. 3I Atlas was being nudged off its expected course, not by random bursts of outgassing, but by a steady, measurable acceleration. This was not drift, it was propulsion. The numbers were stark, a force on the order of 410 meters SAID, meters per second squared. On Earth, that's almost nothing. In space, where there's no air resistance, it's colossal. Over weeks, it moved 3I Atlas thousands of miles from its gravity-only path. And then came the comparison no one expected. The measured thrust matched that of ion drives, the highly advanced engines we put on probes, like NASA's Dawn spacecraft. Ion drives generate only a whisper of force, less pressure than a sheet of paper on your hand, but they run continuously, accelerating a probe across millions of miles. 3I Atlas appeared to be doing the same thing. This is where NASA's language grew careful, even nervous. The report spoke of non-gravitational acceleration and sustained outflow, but they didn't hide the fact. The acceleration lined up perfectly with the object's plume. It was moving in the direction it shouldn't be, and the push was consistent. For scientists used to messy, unpredictable comets, this was unnerving. Natural jets are chaotic, spraying from cracks in the ice, turning a comet's spin erratic. But this was no random spray. This was focus, precision, a steady plume, firing like an engine against the sun. Quietly, astronomers began to whisper what the official reports couldn't say out loud. This didn't look natural. It looked engineered. And the most shocking part, NASA didn't deny it. They published the numbers, they shared the impossible images, and in doing so, they left the door wide open for a conclusion too uncomfortable to state. This wasn't just a comet, it was something else. If the strange, engine-like tail of 3I Atlas was the first shock, the second came from what that tail was made of. When the James Webb Space Telescope turned its unmatched infrared eyes toward the interstellar visitor, scientists expected a typical cometary spectrum: water ice, carbon dioxide, maybe some methane or ammonia. Instead, what Webb found was unlike anything in the catalogue. The analysis revealed a chemical fingerprint dominated by carbon dioxide at an 8-point ratio over water. In every comet studied within our solar system, the balance is far more even. Some lean toward water, others toward carbon dioxide, but nothing approaches the overwhelming dominance seen in 3I Atlas. This ratio alone was enough to classify it as an anomaly. But the surprises didn't stop there. Webb's instruments picked up an unusual amount of atomic nickel vapor surrounding the comet. Nickel, forged in the hearts of dying stars, is almost always paired with its cosmic twin, iron. The two metals are practically inseparable, born in the same stellar furnaces, deposited together in the same proportions across asteroids, meteorites, and planets. Yet here, in this so-called comet, nickel was abundant and iron was completely missing. For astronomers, this was like finding footprints in the snow with no trail leading to them. Something fundamental was out of place. The implications were staggering. Natural processes don't easily separate nickel from iron. They condense together, they bind together, and they are destroyed together in supernovae. To have one without the other would require conditions or processes that we simply don't see in nature. Unless, of course, the separation was intentional. Some researchers speculated that the nickel vapor could be the result of exotic outgassing, or perhaps the comet formed in a unique stellar nursery where conditions favored one element over the other. But no models fit neatly. The mystery deepened when astronomers calculated how much nickel was present, far more than could be explained by random ejection. It seemed concentrated, as if deliberately released. If the physics and chemistry of 3I Atlas weren't strange enough, its path through the solar system raised even more eyebrows. Astronomers are used to interstellar objects barreling through on odd, slanted orbits. They come in fast, cut across the planetary plane at steep angles, and vanish forever. That's what randomness looks like. But 3I Atlas wasn't random. Its orbital inclination was measured at just 5 degrees off Earth's own orbit around the Sun. That's nearly coplanar, a match so close it felt uncanny. The statistical odds of such an alignment happening by chance, roughly 1 in 500. Already unusual, but still explainable as coincidence. Then the projections came in. Over the next year, 3I Atlas would perform a sequence of flybys, not grazing collisions, but close approaches to Mars, Venus, and Jupiter. 3 major planets, one after another. This wasn't just a lucky pass, it looked more like a tour. NASA's dynamical simulations showed the probability of such a sequence being random was less than 1 in 20,000. In other words, astronomers might have to observe tens of thousands of interstellar visitors before seeing a trajectory this friendly again. That comparison hit hard because the pattern looked eerily similar to how human spacecraft use gravity assists. Missions like Voyager or Cassini slingshot around planets to adjust their speed and direction without burning fuel. It's a choreography of precision, a cosmic dance where every flyby is planned decades in advance. 3I Atlas seemed to be doing the same thing, passing Mars, then Venus, then Jupiter, as though it were deliberately collecting encounters, harvesting data, or adjusting its path. Each pass perfectly timed, perfectly aligned. Of course, the official line was caution, rare but within possibility. Scientists hate to jump to extraordinary claims without airtight evidence. But behind closed doors, some couldn't shake the feeling that this wasn't a random traveler. It was a guided visitor. When combined with its engine-like plume and bizarre chemistry, the trajectory made 3I Atlas look less like a comet and more like a mission. And if it was a mission, then the question became unavoidable: who sent it? Every object in the solar system follows one master: gravity. The pull of the sun dictates the arcs of planets, asteroids, and comets, bending their paths in perfect, predictable ways. When something strays from that rule, astronomers take notice. Atlas wasn't following gravity alone. Its position, tracked night after night with high-precision astrometry, revealed a constant, measurable push. Astronomers call this phenomenon non-gravitational acceleration. Small nudges caused when jets of gas erupt from a comet's surface, acting like tiny thrusters. Usually, these effects are messy and random, creating slight deviations. But in 3I Atlas, the push wasn't tiny. It wasn't random. It was focused, steady, and far too powerful. The measured acceleration was 4 pex 10 meters save meters per second squared. To most of us, that number means nothing. But in space, it's extraordinary. Over a few weeks, such a steady nudge moved 3I Atlas thousands of miles from the trajectory gravity predicted. Here's why that matters. For a comet to generate that much thrust naturally, it would need to lose 10 times more mass than what telescopes actually detected. In other words, If 3I Atlas were truly just outgassing like a normal comet, we should see an enormous cloud of water vapor, dust and debris. But we didn't. The coma was too faint, too small, to account for the measured force, so the models were tested again. Teams ran simulations of sublimating ices, water, carbon dioxide, even exotic hydrogen. None of them produced enough thrust without blowing the comet apart. None of them explained the plume pointing sunward. The only model that matched reality was unsettling, a directed jet of heavy dust grains firing continuously from the sunlit face, a jet with focus like the exhaust of a machine. The estimated thrust? Around 0.4 millinewtons, which happens to be in the same range as the iron engines NASA uses on its most advanced probes. That comparison was hard to ignore. Human engineers designed spacecraft to operate with exactly that kind of low but steady thrust, trading brute power for precision and efficiency. It's how missions like Dawn explored the asteroid belt, inching their way across millions of miles with a continuous whisper of acceleration. And now, a so-called comet from another star system was demonstrating the same trick. Coincidence? Possibly. But when physics, chemistry, and trajectory all point to anomalies, coincidence starts to sound like denial. The truth was impossible to miss. 3I Atlas was moving as though it had an engine, and if it did, then humanity wasn't just observing a comet. We were witnessing technology, one that didn't come from Earth. To understand why 3I Atlas rattled the scientific community so deeply, you have to go back to October 2017. That's when the Pan-STARRS telescope in Hawaii spotted a faint, elongated object streaking through the inner solar system. It was the first confirmed interstellar visitor humanity had ever detected, and its name quickly became famous: Oumuamua. At first, astronomers thought it was just a rock from another star, but within weeks the strangeness piled up. Oumuamua wasn't behaving like any asteroid or comet we knew. Its shape was bizarre. Some analyses suggested it was long and cigar-like. Others said flat and pancake-like. Its surface was unusually shiny, reflecting sunlight more than expected. And strangest of all, as it sped away from the sun, it began to accelerate. Just like 3I Atlas, its motion couldn't be explained by gravity alone. But unlike Atlas, Oumuamua had no visible tail. No gas jets, no coma, no evidence of outgassing at all. Yet something was pushing it. The debate that followed was explosive. Some astronomers argued it must have been shedding invisible hydrogen or icy fragments too faint to detect. Others weren't convinced. The most famous counterpoint came from Harvard astrophysicist Avi Loeb, who proposed something radical. Oumuamua might be artificial, a thin, light sail pushed by sunlight, the kind of technology a civilization might use for interstellar travel. The scientific establishment recoiled. Alien explanations are usually the last resort. Papers poured out trying to explain Oumuamua as natural, an icy shard, a nitrogen iceberg, even a fragment of a tidally disrupted planet. None of the models fit the data perfectly. By the time Oumuamua vanished into the dark, it left behind more questions than answers. Fast forward to 2025, and here was 3I Atlas arriving with uncanny timing. Where Oumuamua whispered mysteries, Atlas shouted them. The first had no tail, the second flaunted one. The first accelerated invisibly, the second displayed propulsion in full view. The first vanished without a trace, the second is lingering, giving us months to study its every move. To many, it felt like a pattern. Not one anomaly, but two. Not a coincidence, but a sequence. If Oumuamua was the teaser, 3I Atlas was the sequel. A louder, brighter, more dramatic act in a story still unfolding. This is what unsettled astronomers the most. Two interstellar visitors, less than a decade apart, both breaking the rules of astrophysics. Statistically, that's astonishing. If these were natural oddities, why would we stumble on two in such rapid succession? Unless, perhaps, they weren't oddities at all. For the first time, many began to wonder, what if these weren't accidents of nature? What if they were part of something deliberate? Probes, messengers, or even experiments passing through our corner of the galaxy. Oumuamua was the first knock at the door. 3i Atlas might be the second, and if that's true, the question becomes chillingly clear. What happens when the door finally opens? By the time 3i Atlas's plume and acceleration were confirmed, the astronomical community had fractured into two camps. On one side were those insisting there must be a natural explanation, some exotic physics or chemistry we had never seen before. On the other side were those whispering that maybe, just maybe, it wasn't natural at all. Scientists are reluctant to abandon natural models. Some argued that 3i Atlas might be venting unusual ices, perhaps solid carbon dioxide or exotic hydrogen deposits that behave differently under solar heating. Others proposed that its plume wasn't a jet at all, but a dust-driven instability we had never encountered before, unique to interstellar comets. A few even speculated it could be a fragment from a dead, distant star system, where chemistry followed rules unlike our own. But these explanations were thin. None accounted for the plume's precision, the nickel without iron signature, or the perfectly timed trajectory. The models strained under the weight of anomalies. That's when more provocative theories began to surface. The Bracewell probe hypothesis. First proposed in the 1960s, this theory imagines advanced civilizations seeding the galaxy with autonomous probes designed to watch, listen, and perhaps one day make contact. To believers, 3i Atlas fits the mold perfectly, a machine disguised as a comet adjusting its course, revealing itself just enough to test our awareness. The terraforming machine theory. Others took the strange chemistry as a clue. What if the overwhelming carbon dioxide and the isolated nickel weren't random? What if they were a payload, materials meant to alter planetary atmospheres? Could 3i Atlas be a kind of cosmic seed, dispersing elements across star systems to prepare worlds for life? The smoke signal concept. A more radical idea was that the comet's impossible behavior was itself the message. By breaking natural laws so blatantly, 3i Atlas might be broadcasting a cosmic hello, a puzzle designed to draw attention from any civilization advanced enough to notice. In this view, the plume is a signature, a deliberate anomaly meant to test our intelligence. The darker allegations. And then there were those who whispered the unnerving possibility that 3i Atlas wasn't alive or functioning at all, that it was wreckage, a drifting shard of technology from a conflict we can't imagine, bleeding exotic gases as its systems fail. Each theory carried weight, but none brought comfort. If natural, 3i Atlas forces us to rewrite physics. If artificial, it forces us to admit we are not alone. And if debris, it hints at a universe where survival is not guaranteed. What united every perspective was the same uneasy truth. 3i Atlas was not behaving like a comet. It was behaving like a message. Some astronomers are willing to toy with the idea of 3i Atlas as a probe. Fewer are willing to whisper the darker possibility. What if it isn't a messenger, but a warning? This line of thought draws on the dark forest hypothesis, a concept from astrophysics and science fiction that suggests the universe is quiet, not because life is rare, but because life is terrified. Imagine a cosmic forest at night. Every civilization is a hunter with a gun. To reveal yourself, to shout, to light a fire, to broadcast your presence is to risk attracting a predator. In such a universe, survival depends on silence. If that is true, then an object like 3i Atlas becomes chilling. A comet that acts like a machine, arriving with impossible precision, could mean one of two things. Either it belongs to the hunters, or it's the corpse of prey. One unsettling theory is that 3i Atlas is not functional at all. It could be the shattered remnant of a larger spacecraft, limping along as its systems bleed exotic materials into space. Its strange nickel vapor, its off-balance CO2 ratios, not design, but decay. In this scenario, we aren't looking at a probe performing a mission. We're looking at the wreckage of an interstellar war we know nothing about. That possibility terrifies researchers because it implies the galaxy is not a playground of curious neighbors, but a battlefield, and Earth has just stumbled across a piece of evidence. Another disturbing scenario suggests that 3i Atlas may be bait. By behaving so impossibly, it forces attention. It practically dares us to notice, to track, to send signals, to reveal ourselves in the process. If the dark forest hypothesis is true, that might be exactly the wrong move. Scientists rarely put such ideas in official papers, but in private conversations, the fear lingers. Not every anomaly is benign. Not every visitor is a friend. Whether it is a probe, a payload, or debris, 3i Atlas forces humanity to confront an unsettling truth. The cosmos may not only be stranger than we imagine, it may be more dangerous. And as it nears its critical perihelion passage, hidden behind the glare of the sun, the timing feels too perfect. If ever there were a moment for a machine to hide a maneuver, or for wreckage to vanish forever, this is it. The question is not just what 3i Atlas is, but whether we should even want the answer. In just weeks, 3i Atlas will reach the most dangerous, most telling point in its journey, perihelion, its closest approach to the sun. Under normal circumstances, this is when a comet reveals its true nature. The heat strips away its surface, jets erupt, and the nucleus either survives intact or crumbles into fragments. But 3i Atlas is no ordinary comet. Its physics, chemistry, and path have already broken every rule, which means perihelion isn't just an astronomical milestone, it's a moment of truth. Here's the problem. When that moment arrives on October 30th, 2025, Earth won't be able to watch. As Atlas whips behind the sun, every telescope we have, Hubble, James Webb, ground-based giants, will go blind in the blinding glare. For weeks, the object will vanish into solar conjunction, hidden in the one place we cannot look, and to many, that timing feels far too convenient. If 3i Atlas is natural, perihelion will either break it apart or exaggerate its already strange behavior. But if it's something more, if it's a machine, a probe, or worse, then this is the perfect cover. In celestial mechanics, perihelion is the moment of maximum energy. A tiny nudge at that point, a controlled burn, a shift in trajectory can change a path by millions of miles later. If you wanted to hide a maneuver from every civilization watching you, this would be the exact time and place to do it. And that's what has astronomers nervous. Because when 3i Atlas re-emerges from behind the sun, its position in the sky will tell us everything. If it continues along its predicted arc, the story may settle. A strange comet, yes, but one still bound by natural laws we just don't yet understand. But if its trajectory shifts in ways gravity cannot explain, the conversation will change forever. It will no longer be a matter of what comet is this, but who built it. The stakes couldn't be higher. If the trajectory proves artificial, humanity will be forced into a conversation it has avoided for centuries. We are not alone. And not only are we not alone, we are being observed. What happens then? The implications stretch into every corner of our civilization. Science would be upended, astrophysics textbooks rewritten overnight, theories of cosmic formation replaced with a new paradigm of intelligence at the galactic scale. Religion would wrestle with the meaning of life beyond Earth. Was this the Creator's broader design or proof of forces indifferent to human faith? Politics would fracture, nations scrambling to control the narrative, to weaponize knowledge, to claim first contact for themselves, and culture would change forever. No movie, no myth, no bedtime story would feel the same when the universe itself had spoken back. But there are darker possibilities too. If 3i Atlas is a probe, perhaps it is simply observing, watching to see if humanity is ready. If it's a messenger, maybe it carries a signal, waiting for us to prove we can decode it. But if it's a warning, or worse, debris from an interstellar conflict, then its arrival carries a message we might not want to hear. The universe is not safe. The chemical anomalies could be exhaust or payload. The trajectory could be chance or choreography. The propulsion could be physics we don't understand, or the unmistakable hand of engineering. Every explanation splits us between wonder and dread. And so, as the date approaches, astronomers find themselves in a rare position, united in anticipation, divided in interpretation. When the object emerges from solar conjunction, telescopes will be waiting, ready to measure its position to within inches. If it has deviated even slightly from the course gravity demands, the headlines will write themselves. Until then, we wait. Humanity has always stared at the night sky with questions, but this time, the sky is staring back. Imagine it, A comet that shouldn't exist, carrying a tail that acts like an engine, flying a path too perfect to be random, shedding chemicals that defy stellar logic, and vanishing behind the sun at the exact moment when its secrets matter most. Coincidence? Or choreography? Nature? Or design? The truth is coming, and when 3I Atlas reappears from the sun's glare, it may bring with it the answer to the oldest question of all. Are we alone? And perhaps, more chillingly, do we even want to know?